Thank you very much, Mr. Chairman, members of the planning group, Ram. Thank you for convening us. It really is a privilege to be here among so many giants in this room, both intellectual giants and moral giants, as we do our work together. And I need my slides up. Thank you. We are altering our infinitely beautiful, complex, and precious planet. Much of our conversation today has been on the question of how our actions undermine nature. I'll invert that question and talk for a few minutes about, if we undermine nature, how do we undermine our own health and well-being? The emerging field of planetary health proposes that Earth system changes are now so far-reaching that they drive a substantial and increasing proportion of the global burden of disease. Earth system changes are now so far-reaching that they drive a substantial and increasing proportion of the global burden of disease. We depend on stable Earth systems to survive and thrive. Environmental destruction amounts to self-destruction. We need to understand these consequences and commit to wise corrective action. In the next few minutes, I'll take up 4 examples of global environmental changes and how they affect human health and well-being. The first will be climate change, which has been most of our focus so far today. But even if there were no climate change, we would still need to have this conversation because other global environmental changes, other planetary boundaries that we are exceeding also affect human health and well-being. I'll discuss 3 of those: chemical contamination, land use changes, and biodiversity loss. For these 4 examples, the science paints a clear and sobering, if not yet complete, picture. Global environmental change threatens human health and well-being. And the science, in turn, raises both conceptual and ethical questions with which I'll close. Well, this is a climate change diagram. This is a variant of the diagram that Dr. Xiong showed us earlier, and I won't belabor it, just to say that there are multiple pathways through which climate change affects health. Primary impacts mediated through heat and severe weather events. Secondary impacts mediated through Earth system changes, such as infectious disease risks, and tertiary impacts mediated through complex social phenomena, such as the armed conflict and migration that we heard about earlier as well. Importantly, every major category of human suffering is affected: infectious diseases, non-communicable diseases, traumatic injuries, mental distress, and mental illness. Let's consider just one pathway, the one that seems simple but isn't, and that's heat. Well, I'm missing some slides here. Heat-related medical diagnoses, from the relatively benign heat rash to the potentially fatal heat stroke, are well known. During heat waves, in addition to those diagnoses, people die, especially of cardiovascular diseases, especially the very old, the poor, the socially marginalized, and people with certain medical conditions. The numbers can be frightful: 70,000 deaths during the 2003 European heat wave, 54,000 during Russia's 2010 heat wave, and uncounted thousands in India each summer, 2010, 2013, 2015, 2016. People can adapt to heat, but only to a point. And as we heard earlier, with more frequent, more intense, and longer-lasting heat events coming, that point will be increasingly exceeded. But here's where the story gets complex. Heat threatens health and well-being in many less obvious ways. Violence and crime rates rise on hot days. Self-harm may rise as well. Some data suggest an association between heat and suicide. Heat seems to increase the risk of kidney disease, a problem seen in low-income countries where workers toil on high temperatures without adequate rehydration. In hot conditions, it's more difficult to protect food and water from bacterial contamination. Diarrheal diseases such as Shigella rise during hot weather. Hot weather undermines sleep, and sleep deprivation is a risk factor for many diseases. People reduce their physical activity during hot weather, increasing their cardiovascular disease risk. Similarly, heat reduces work capacity to the point that economic output is declining substantially in very hot places, compounding poverty in such places. Workers are affected in another way. Workplace injuries rise during hot weather. Through these and other pathways, from sleep loss to food poisoning to the deepening of poverty, heat threatens health and well-being. And heat is just one of the pathways through which climate change undermines public health. A second planetary change is the widespread dissemination of synthetic chemicals through the world's ecosystems. Plastics, which are polymers of simple molecules such as ethylene, propylene, and styrene, are emblematic. Large-scale production of plastics began after World War II and has now reached 300 million metric tons per year, or about 40 kilograms for each man, woman, and child on Earth, accounting for about 4% of global petroleum use. That means that on average, each human being now alive will account for over 2,800 kilograms of plastic production over his or her lifespan, or 30 or 40 times our body weight. Plastics are persistent. If Michelangelo had sipped water from plastic bottles while painting the ceiling of the Sistine Chapel 500 years ago, those plastic bottles would still be with us. As one commentator put it, with just a bit of hyperbole, every piece of plastic ever made still exists today. Actually, some plastics will degrade after 4 or 5 centuries, and slightly more than a tenth of all the plastic ever made has been incinerated. But that still means that for every human being now alive, there is somewhere in the world about 1 metric ton of plastic. Over half of it is waste, some in large pieces, some pellet-sized, some broken down to microplastics. Where is this waste? Some of it's in landfills. Some of it's in waterways, a common and heartbreaking sight in many of the world's major cities. Plastic generally floats, so it travels with currents and accumulates in eddies, forming patches that can be as large and imposing as islands. From streams, rivers, and harbors, the plastic waste winds its way to the oceans, an estimated 4 to 12 million tons per year. Driven by wind and currents, the plastic seems to go everywhere, making this a global problem. It's been found in the deepest ocean trenches, in Arctic ice, in Mongolian mountain lakes, on remote island shores. The world's ocean systems tend to concentrate waste in the 5 great ocean gyres that are pictured on this map. The highest concentration of plastic debris ever measured on a beach was on remote Henderson Island on the western edge of the South Pacific Gyre, 5,000 kilometers from the nearest significant human habitation. These plastics permeate ecosystems. We now know that birds confuse plastic bits with food and ingest the plastic but cannot digest it. An estimated 90% of seabirds now have plastic in their bodies. The albatross, pictured here, is one such bird. Traditionally a sign of good luck for sailors, later a sign of guilt, thanks to Coleridge's Rime of the Ancient Mariner, it takes on new metaphorical power in the Anthropocene as a graphic warning of our environmental recklessness. The seabird over the ocean as the planetary health equivalent of the canary in the coal mine. Nor are birds the only affected species. In one recent study, fish and shellfish from markets in Indonesia and California were assessed for plastic debris. There it was, in a quarter of the individual fish sampled and well over half the species sampled in both countries. When we eat fish, we are eating plastic. And plastic isn't just plastic. About 7% on average consists of plasticizers, flame retardants, and other additives. And plastics efficiently absorb synthetic organic chemicals to their surfaces. Many of these chemicals, such as polychlorinated biphenyls or PCBs, are highly persistent in the environment, hence the term persistent organic pollutants, or POPs. Indeed, environmental loading with such chemicals is a defining feature of the Anthropocene. POPs are fat-soluble. They bioconcentrate within the fat of organisms such as fish, cattle, and polar bears. They're biomagnified as they move from lower to higher trophic levels of food webs. And they're now globally distributed, even in ecosystems such as the Arctic, far from where they were ever produced or used. With POPs so widely distributed, human exposure is unavoidable. Population sampling shows nearly ubiquitous body burdens in human populations. Many of these chemicals affect neurodevelopmental, endocrine, metabolic, and other delicately balanced systems in humans and in animals. For example, chemicals such as PCBs, bisphenols, and some pesticides act as endocrine disruptors, blocking or activating receptors in sex hormone, thyroid, and other pathways. Evidence suggests a surprisingly wide role for these exposures in non-communicable diseases: diabetes, obesity, and lipid abnormalities, non-Hodgkin's lymphoma, cancers of the breast, ovaries, and prostate, thyroid disease, neurobehavioral disorders, and reproductive dysfunction. One recent study of Inuit people in the Canadian Arctic found that those with the highest blood levels of PCBs were 2 to 4 times more likely to have diabetes than those with the lowest levels. We don't fully understand the geographic extent of global chemical contamination, its pathways through ecosystems, its full impacts on human health, to what extent these exposures account for rising trends in some diseases, where are the boundaries we should not cross. But as the Lancet Commission on Pollution and Health recently made clear, this planetary change does no favors to ourselves or to ecosystems. A third example of global environmental change that affects human health is land use change. Human population growth and resource demands have led to dramatic expropriation of land and water globally. We've transformed as much as half the world's ice-free land surface, much of it from grassland or forest to cropland and pastures for grazing. These changes threaten many species, including us. Consider 2 examples. The first is infectious disease. Land use change and resulting ecosystem alterations can propel diseases as diverse as malaria, schistosomiasis, Lyme disease, and West Nile. Many mechanisms operate, from changes in microbial ecology to increased contact between humans and vectors. A recently published example is instructive. Scientists based at University of Vermont were interested in the effect of degraded watersheds on children's health, specifically on diarrhea, the second leading global cause of death among children under 5. They studied nearly 300,000 young children in 35 countries, focusing on measures of watershed quality, the influence of upstream livestock grazing, people, and tree cover on downstream water quality. The researchers found that more intact tree cover in the upper watershed reduced downstream rural children's probability of diarrhea. In fact, 30% more tree cover upstream was as protective as a classic public health intervention, sanitation infrastructure. Healthy tree cover in a watershed is good for human health. A second example of the impact of land use change on health comes from palm oil plantation in South Asia. Production is increasing as a result of demand for biofuels in Europe and food in India, Indonesia, and China. Oil palm plantations affect local ecology. They are far less biodiverse than primary forests. To clear tropical forests in Indonesia for palm oil production, as well as for other purposes such as timber plantations, fire is commonly used. The resulting smoke blows in defined ways, affecting populations in Indonesia and the Malay Peninsula. Researchers at Harvard have studied the Indonesian fires, combining data on land types, land use, fire occurrence, wind patterns, smoke composition, and health outcomes. Among their findings, the Indonesian fires caused roughly 11,000 excess deaths in the region in an average year. And in an exceptionally bad year, 2015, the toll was an order of magnitude higher, at just over 100,000 excess deaths. Not only that, the forest combustion and peatland loss contribute to climate change, and dietary palm oil contains highly saturated fatty acids that may raise the risk of heart disease and other NCDs. Land use change matters for human health. The final form of global environmental change I'll mention is biodiversity loss, which I can't do nearly as well as Peter Raven is about to. But I will describe 2 pathways from biodiversity loss to human health: pollinator loss and fisheries depletion. Pollination by insects is an important form of reproduction for more than 35% of the annual global food production by volume. At least 87 major food crops and up to 40% of the world's supply of some micronutrients, such as vitamin A, depend on pollination by insects. Pollinators are declining in many parts of the world, probably for a combination of reasons, including habitat loss, pesticide use, and parasitic infections. Pollinator loss can reduce the amount of fruits, vegetables, nuts, and seeds in the diet, contributing to vitamin A and folate deficiencies. A recent analysis projects that a 50% loss of pollination would cause about 0.7 million additional deaths worldwide, mostly as the result of increased ischemic heart disease and stroke due to reduced fruit and vegetable consumption. Fisheries depletion has emerged as a global problem, with about 90% of fisheries now at or beyond maximum sustainable levels of exploitation. Climate change will intensify this problem in coming decades. For many populations, fish are a leading source of protein, of micronutrients, often in highly bioavailable form, and of omega-3 fatty acids. One study projected that more than 10% of the global population could face micronutrient and fatty acid deficiencies due to fish declines over coming decades, especially in low and middle income countries. Fortunately, there is some indication that with aggressive management, collapsed fisheries can recover, as may be happening with the North Atlantic cod fishery, which abruptly collapsed in 1992. Aquaculture is to some extent replacing wild fish catches, but much aquaculture depends on external feedstocks that may be unsustainable, and challenges such as diseases in farm fish, chemical contamination, genetic contamination of wild fish, and pollution of water near fish farms all must be addressed. These four sets of examples, climate change, chemical contamination, land use change, and biodiversity loss, together paint a compelling picture. Human disruptions of planetary systems threaten human health and well-being. Those who are most at risk are those who live each day with high levels of risk due to poverty and deprivation. Well, this has been a grim litany. Indeed, planetary changes are threatening human health and well-being, even civilization as we know it, on a frightening scale. But the news is not all bad. Some planetary changes may offer benefits, such as higher agricultural yields or more physical activity in cold areas that are becoming warmer. More importantly, the steps we need to take to address planetary challenges, such as climate change, yield a range of co-benefits, such as stronger communities, cleaner air, and more wholesome food. Andy Haynes will discuss this later in the meeting, but in the meantime, the threats I've described call on us to change our thinking as scientists and as global citizens in some fundamental ways. First, we need to learn to acknowledge and live within limits. All of us have lived our lives during a time of plenty unprecedented in human history, enabled, of course, by our profligate consumption of energy and materials, propelled by ever more powerful technologies. Those of us in wealthy nations are no more conscious of our extravagance than fish are conscious of water. And as we've learned from recent behavioral economics research, we humans are not wired to confront limits. We're biased toward short-term thinking, we discount future consequences, we resist risky change. We need to work to replace profligacy with restraint, extravagance with modesty, wastefulness with thrift. Second, we need systems thinking. Every serious thinker about sustainability or climate change or human affairs in general knows that reductionist linear thinking misses the mark. Nowhere is this more true than in planetary health. But too many of our institutions remain siloed. Too many donors are infatuated with silver bullet technical solutions rather than aiming for patient, long-term adaptive management of complex systems. In my own field, medicine, why do we still require prospective students to have studied chemistry, physics, and calculus, but not ecology and evolutionary biology? We need habits of thinking and institutional arrangements based on systems. Third, we need a sense of urgency. Our house is on fire, and we need to act accordingly. Our scientific discourse is typically dispassionate, but passion in this setting is no sin, it is a necessity. 50 years ago, discussing a very different emergency, the Vietnam War, Martin Luther King wrote words that are deeply appropriate today. Quote, "We are now faced with the fact, my friends, that tomorrow is today. We are confronted with the fierce urgency of now. In this unfolding conundrum of life and history, there is such a thing as being too late. Procrastination is still the thief of time. As it was for Reverend King then, so it is for us now. We must confront the fierce urgency of now." Fourth, we need intellectual humility. Modern science and technology, animated by positivism, have delivered untold benefits to humankind, but they've also brought wicked problems and profound dilemmas. Science and technology do not offer all the answers. We scientists need to be open to other intellectual traditions, to faith traditions, and I so appreciate the Pope and the Pontifical Academy for engaging the challenges of climate change and health and for convening us. And we need to be open to the traditional ecological knowledge of indigenous peoples. This will take us beyond our comfort zones, right where we need to be as we stretch towards solutions. And finally, a word about ethics as I close. As a medical student and young physician, I learned and took seriously the principles of biomedical ethics: respect for autonomy, non-maleficence, beneficence, and justice. And those principles guided some sound decisions. Don't treat a patient without his or her consent. Don't withhold information from a patient. But that ethics doesn't go nearly far enough. We need an ethics that recognizes everybody's right to have access to the clinic in the first place. And not only to the clinic, but to all the precursors of a fully expressed and healthy life: education, housing, political voice. We need an ethics that recognizes intergenerational responsibility. Our obligations extend far beyond our lifetimes. Finally, we need an ethic that extends from humans to the more than human world. As much as we bear responsibility for each other, we bear responsibility for other species and for ecosystems. Our ethics must be grounded in our place as part of the larger world we share. Thank you very much.